Hi, everyone. Welcome to today's session. Today, we'll discuss modern analytic architecture and automating pipelines and how AWS enables this along with our partner SN. As you may all know, the data volumes are increasing at an unprecedented rate. They're exploding from terabytes to petabytes and sometimes even exabytes of data. The traditional on-premises data analytics approaches can't really handle these data volumes anymore because they don't scale well enough and they are way too expensive. We hear from our customers and companies all the time that they're looking to extract more value from the data, but they're struggling to capture, store, and analyze all the data generated by today's modern and digital businesses. Data is growing exponentially and it's coming from new sources. I mean, it's not just the traditional structured data sources. Now you have data coming from like social media, from video streams, video metadata, from like other sources like Twitter and web streams and clickstream data, and it's very diversified now. The data in terms of the the structure, in terms of velocity, and the data needs to be securely accessed and needs to be analyzed by different application and by a lot of other different people from across different teams. Against this backdrop of increasing data volumes and the desire to get the right data to the right people, the last few years have shown us what we need to do to be prepared to deal with such changes. We can't predict the future, as we all know, but we can put in place the infrastructure and the tools required to adjust to changes as quickly as possible. Our data helps us to identify changes, and the right data and analytics approach helps us to make the right decisions quickly as changes occur. Our AWS analytics customers are doing just that, allowing them to navigate that what has been challenging last few years. And as you all may know, last few years have been really out of normal for the world, right? The COVID has like put us in a different position where the traditional rules have been kind of thrown out of the window. We have seen how our customer have adjusted in these times, and thank for the infrastructure and services they're able to offer. Our customers have been able to change their businesses as and when required. We have seen customers in segments like travel and lodging, for example, who had to scale down their footprints when things spiked in March, April. Then they had to scale them up rapidly as the segments recovered. And we have seen others also in segments like e-learning and healthcare who have seen the need for scale and analytics at levels they haven't imagined at the start of the year. Two great examples I'm going to share, which kind of throw the spotlight on how AWS have helped customers during these times is example of Wire and Moderna. So Wire, as you all may know, is have been manufacturing ventilators, and before COVID actually hit, like the volume of ventilators were just like not that much, but soon once the need for ventilators like increased because of COVID, the scale has to be increased by a factor of 20. Including a US government order of more than 20,000 ventilators, which was placed with Wire. Now, if it was other time, it was hard for Wire to kind of scale up because they would not have been prepared for such a scale increase of scale. And just for a perspective, Wire was producing around 30 ventilators a week before COVID hit. A few months into pandemic, the company was producing around 600 a day. Every product had to meet tight regulations, even as urgent demand skyrocketed in the United States and around the world. For YA, the biggest project was the US government ordering of 20,000 ventilators. And they partnered with like aerospace company called Spirit Aerosystems to temporarily convert an airplane component factory into a critical care ventilator factory. They had to replicate from both a process and an engineering perspective. A highly customized manufacturing process for the line of ventilators. It was like 20 times beyond what they have been doing. The ability to scale was only possible because of Wire's newly modernized analytics solution, which was built on Amazon S3 with Redshift as the data warehouse. For example, the ability to analyze data quickly at scale enabled them to greatly increase the first pass yield, which measures the rate at which the product passes the final test on the first attempt and is ready for distribution. In near real time, Wire was able to load data into the data warehouse and push into the relevant parts of the production line. By doing so, it could provide supervisors the information they needed to iterate the pieces of the process and improve the total throughput. The next example use case I would like to share is Moderna. Bringing new drugs to market can take a decade, as we all know, and it can cost excess of $1 billion. A scientist need like years of basic research. They need to screen thousands of compounds and then move them to the lab testing and trials. And these data are often siloed and have limited scalability in traditional on-prem system. And this is a challenge. So Moderna Therapeutics was founded in 2010 with a goal of delivering on the promise of messenger RNA, which stands mRNA in short. It's a science to create novel medicines for unmet patient needs. As you may have heard in the headlines, Moderna is one of the leading companies working who actually worked to have produced the COVID vaccine. They invented proprietary technologies and methods that run on AWS to create mRNA constructs that cells recognize as their own, a part of their body. This invention has empowered Moderna to experiment rapidly on virtually any mRNA sequence, easily shifting between the research priorities without investing in new technology. And that's a huge cost saving right there. So what Moderna does like behind the scene is that they are using Redshift for simple, cost-effective data warehousing to avoid silos and establish like single source of truth for the company. By using Redshift as central repository, the company can capture all the data once with little manual effort. And they can use the BI data science tools to give the scientists access to like visualization that can help them with correlations. They can help them to develop insights, and they can also back and push these outcomes to S3, which is highly scalable and durable data store. Redshift, along with other AWS technology, is helping scientists and engineers aggregate results from dozens of experiments that are running in parallel and easily query, share, and insights to refine the design and production cycle quickly. So let's talk about how customers are evolving their data architecture to analyze the vast amounts of data in easy and cost-effective manner. So what has happened if you look at the diagram, there's a left side and the right side. So what has happened over the last number of years is that the customers accumulated so much data, a lot of that data is now sitting in different silos. An example of these silos is like a marketing team has their own silo, a sales team working on their own silos. And over a period of time, like, more and more silos have been created in the traditional on-prem system. And it's hard to really do analytics when your data is stuck in different silos. The silos can cause multiple problems, like because they live in their own different security domain. They may have the different SLAs and different hardware for those SLAs, and also kind of getting them together may not be so straightforward and easy for the analysts and the teams. So these silos may require different management and security approaches, which could increase the operation cost and also risk, because if we can't get the data timely, then it kind of, we face a risk on that untimeliness of the data. So customers are looking for a highly scalable, available, secure, and flexible data store, or data lake in short, that can run these extreme large data sets and give the right results and timely results. So with the data lake, customers can store all the structured and unstructured data using the standard open data format of the choice, like ORC, like Parquet, and then they can tag it into a central searchable catalog. But they need to do more than this. They need to be able to like run multiple services against the data in order to ensure that they have right tool for the job. They need to be able to move data between the data lake and the services in all directions from inside out. As you see in the diagram, we have this like we have like almost like a wheel, like a flywheel, and they have like different like circles, like so if you look at like this middle, that's where the data is stored, like in terms of data lake. But there's a need to move data across different directions, so from data lake to the data stores which are around, and also from those data stores back to the data store, and also within those data stores out there. So that data movement is very important for having a living system out there. And then it's not enough to have a living system which can move the data. They also need to have a governance system which can secure the data, where you can manage the data, you can monitor the data, because monitoring is also very important when you're talking about a productionalized data lake out there. And to top of that, we want this to happen at a very low cost, because as a customer, as AWS, we are very kind of big on saving money for the customers, right? And if you see, we have always been reducing cost of our services since last so many years. So yeah, so we need to do all those things, but at the same time, we need it to be cost effective and at scale. So then how do we do it? We do it through something called modern architecture for analytics, and we'll look at that in the next slide. So this is how it kind of comes into the picture, the modern architecture. We use a broad and deep collection of purpose-built databases, or data stores, or data services, however you want to call it, that provide the right performance for the right use cases. It could be interactive dashboards, it could be log analytics, it could be your big data processing, warehousing, and so on. Now, enabling these things, we also need to move data between each services. So we need to have the right tools for that. And we talk about the governance, setting up the governance and also providing this skills. So this is the blueprint of what we call as a modern day architecture. It's just not about integrating with the data lake. That's something which a lot of people get, think that's the end of in data lake, is you have a data store and that's it. But it's not about data store only, because that's the starting of data lake. We need to have the data lake integrated with the data warehouse, and also all the other purpose-built services around it. So there's the constant kind of stream of data which is flowing in and out of the data lake. So this is the key to have a modern day architecture. And let's see how it looks when we build on AWS with the right native services out there. So it starts with Amazon S3, which kind of forms the basis of data lake. So customers have been building data lakes on S3 longer than any other cloud provider and out there. And today, more data lakes run on AWS than anywhere else. And in addition to data lake, customers use a combination of our purpose-built services and analytics services like EMR, like Amazon OpenSearch, right, Redshift, and use the right tool to give the right performance at the right scale at the lowest possible cost, basically. To move the data between these systems, as we mentioned, the movement of data is kind of important. They use something like AWS Glue, which is our serverless way of integrating services. There are different aspects of Glue. There's a cataloging aspect of Glue. There's orchestration or scheduling aspect of Glue, and there's also the execution of jobs running aspect of Glue. So that's what we are talking about here when we talk about moving data between different systems. And finally, we have AWS Lake Formation, which is kind of recently released service. It was released around 2 years ago to manage the security and the governance of all the data, regardless of whether it sits on the data lake or the data store. So think of the Lake Formation as a governance layer sitting on the Glue, which kind of overlaps between the data lake and all the purpose-built data store like Athena or Redshift or EMR. It kind of ties everything together, and that's very important from the governance point of view. And let's talk about the scalability aspect of data lake, because everything at AWS is kind of done at scale, because we understand that it's not good enough to have a solution which works, but also the solution should work at scale, because that's what most of our customers are looking for, a scalable solution. So as an example, this is a slide which gives a snapshot of how customers are achieving the end goals through these modern day architecture paradigms. As you will see, I won't read all the customer names, but some of the key customers is Zappos, right? It's a very it's a very dynamic company out there, and they have been able to improve the customer experience through implementing a modern day architecture. Then there is New Relic, which has actually become more agile, and they have done a lot of innovation through these architectures. There's FINRA, which have saved massive amount of money by managing the massive data they have on AWS. And then there's Wire Medical. We talked about that initially, how they were able to scale up the ventilator manufacturing, and they actually were able to improve the performance through these services and architectures out there. So this is like just a few examples how our customers are able to use the modern day architecture and services to achieve different goals, which at the end are beneficial for the company and the customers. So scalable data lakes, like let's talk about that. Let's start from the middle of the data lake, right? So it's easier to get insights from all our data by providing a single place to access it. So if we have something which is open source, which is based on open source standard like ORC, Parquet, Avro, it also future proofs like the whole data lake aspect, right? Because we know that it's pretty open. We know like in future also if any new tools can come, they can hook up with S3, which is the basis of data lake. Then we for customer point of view, we need a highly scalable and available, secure, flexible data store, and S3 as a data lake actually does that. So AWS have been helping customers build a strong foundation for data lakes through S3, as you may have kind of observed by now. And there are like now thousands and tens of thousands of customers who are using data lakes powered by AWS on S3. The question would come like, why S3, right? Like, why we think S3 is the best tool for this? Well, there are few characteristics of S3 which makes it the best place for storing all the data. It has unmatched durability, availability, and scalability. It has the best security, compliance, and audit like posturing and capabilities. And it is highly performant, and it has very low cost. And within S3 also there are different layers. I don't want to go through them right now, but there's like a hot layer, warm layer, and cold layer depending on the SLAs around data. So it is very diverse ecosystem out there of S3. And also like it kind of supports a lot of integration within AWS services and also within the partner ecosystem out there. So that's also makes S3 a really good candidate for our integrations. And it's also built to store and retrieve like any amount of data because it has unmatched availability. It provides around 11 nines of durability on, which is like very, very like, durable in that sense. So it provides unique capabilities, including like storing customer data as across different availability zones, as we call it AWS. So each availability zones actually, for people who don't know, each availability zone, or AZ as we call, is consisted of at least one data center. And then multiple availability zones actually create a single AWS region. So from the durability point of view, like S3 is doing these kind of replications around AZs, and also like you can do it across regions to kind of secure your data and make it like more durable in terms of in case the outages happen. However, like setting up data lakes and managing is not easy. There's a lot of manual and time-consuming tasks such as loading the data from different sources, monitoring the data flows, setting a partition on S3 for the data, turning the encryption on and off, then managing the keys for that, and organizing into different like columnar format. So all those steps are needed to have a fully functional data lake. And there are native services like Glue we talked about, lake formation, which helps like customers to do that. But in addition, we also have like a very vibrant and strong partner ecosystem, which helps us, which helps like AWS to kind of augment these needs from their products. So SN is one of our very key customers, key partner who helps like in this use case where they helps like to get data into these data lakes. So SN leverages S3 to store partitions between different steps of its data pipelines, where we can query each stage at any time. So this provides like maximum flexibility, transparency, and observability of the transformation which are happening when the data is being moved across different stores and different storage areas and regions within the data lake. So that's very important, and SN does a really great job in kind of doing that. And as well as it can recover from processing errors and infrastructure faults out of the box. So the good news though is that SN can automatically handle these all data partitions and versions. And then also on top of that, it can also track data lineage, like in terms of how the transformation happened, what are the source, and it kind of lets you lets you like have an audit trail of like where the data was changed, how it was changed. So if there were some issues downstream, you can go back and look at the data lineage and kind of track it down. So those things are very important, from a data lake administrative point of view. So that SN does that, for the user, and they do that without writing a single line of code, or actually a minimum line of code in that sense. So they are like a low code, no code solution when it comes to like the pipelines, which we need to kind of put data into data lake, which is needed to support this modern architecture we talked about so far. So let's look at some of the customers which are actually using data lakes out there with modern day analytics. And I won't go through those each customer, but this is just like a snapshot of the key customers which are using AWS for modern day analytics architecture. Let's talk about the purpose-built data services. Like in many cases, this purpose-built data services are optimized for specific use cases. An example I give to everyone is like an example of scissor, for example, right? Now I can take a scissor and I can cut a grass with it, and it will do the job. And I can take the scissor to cut my hair too, obviously, right? But like, if I use the scissor to cut a grass, like it will take like obviously maybe hours or maybe days, depending on the size of your lawn. And so it's not a highly optimized solution. So that's what we call, that's why we put emphasis on the purpose built services, because there is services for you which is there just for a specific use case. And that's why it's important to understand like what are the services which can get you the right result, the optimum result. So we call them as best of breed services, which mean we never have to compromise on performance or scale and cost. For example, Amazon Redshift is like almost 3 times faster and at least like 50% less expensive than any cloud data warehouse out there. And the Spark on EMR, when you run Spark on EMR, although Spark is a open source ecosystem, when you run Spark on EMR, which is AWS EMR, it runs almost like close to 2 times or exactly 1.7 times faster than the standard Apache Spark 3. And you can run like petabyte scale analysis on that. So this is what the value is added through AWS in those tools, which are very purpose-fit. So Ascend, what it does is that kind of Ascend automation ties together many of these services, the AWS services, to provide end-to-end automation. So using Ascend, you can draw data from different purpose-built stores and move it to different stores and transform them in between through pipelines. So you can use like something like Redshift and Spark to actually be the execution of a platform for the pipelines. And you can deliver these data to platforms like DynamoDB and SageMaker. So in terms of like analyzing all the data, right? So there's Amazon Redshift, which is very powerful to do that. It's like one of those, as we said, it's like it is half the cost with like almost like double the performance. So kind of this, and it fits in nicely into the modern day architecture. You can take advantage of real-time analytics. You can have ML AI use cases without re-architecting them, and you can also access like other data stores like Amazon Aurora. It's the only cloud data warehouse that lets you pre-query at like exabyte scale against your data lake, which is a lot of data. And Redshift will also provide like fast performance at any scale. Redshift delivers up to 3 times best performance than other warehouses, cloud warehouses. And the best part is that it has a self-tuning system. So if you have used Redshift like say 5 years ago, there were a bunch of best practices you have to do in terms of configuration to get the best out of Redshift. But now doing, one of the evolution of the Redshift has been is that like, it has become more and more self-tuning. So out of the box, it will self-tune based on your workload and give you the best performance, for the workload you're using. So it's going to auto optimizes itself to give the performance you're looking for. So which is, I think, is very powerful. It shows the innovation which is happening, in the Redshift services team to give those kind of like functionality to the users. And Redshift can scale to deliver consistent data and consistent performance from a few users to 1,000 users. It also supports concurrency scaling, which is really important when you are dealing with like multiple folks with like different workload which they want to run at the same time. Then there's also the advanced query accelerator, which is like a hardware acceleration, which is a recent addition, a functionality addition, which can boost up your queries up to 10 times, which is a big achievement in that sense. There is also going to be a Redshift only session by one of my fellow Amazonian, Manan. So please, take a look at that. Don't miss it out. It's going to be pretty powerful, and he will dig into the Redshift layers and talk about the best practices and how Redshift does the performance so nicely, and also the cost aspect of that. So definitely look into that. What Now Ascend is also like works very closely with Redshift service. They are Redshift ready partner. They can run workloads in Redshift. So while Redshift has everything you need for the data warehouse, it also becomes a part of the data pipeline as well, which is kind of interesting take on the execution of pipeline. For this reason, there is so much emphasis being paid as in the on Redshift for the data automation summit for this year. So yeah, definitely check out like the conversation by the talk from Manan Goyal, who's my fellow Amazonian on Redshift. So as more applications are being built using these architectures and purpose-built store, they produce an ever-increasing amount of log data. That's one of the byproducts of like modern day DevOps and other the microservice approach. There's a lot of data being produced, so you need a way to access all the data, the log data, and to monitor the health of the production systems and troubleshoot the problems. So for that, there is Open Search Service, which is a successor to Elasticsearch Service, which helps you just collect the data, analyze it, and you can visualize it, the semi-structured content. We call it the ELK stack in short, right? Like it's the Elasticsearch, Logstash, and Kibana. That's like basically your whole pipeline. In a DevOps world, that's what it is called. But like with the OpenSearch, you get everything kind of together. So you have it will kind of ingest the data to the integration points. It will have the data stored in it, and then also it will give you a visual dashboard to kind of look at the data, look at the chart, bar graphs. You can query the data, you can tag the data, you can have quite complex queries and joins and everything within like different lookups. So yeah, you can get that all within the open source service. For this example, one of our customer Autodesk is actually they use around 2 terabyte of data to kind of on a regular basis on every day, and then that basically has grown to like almost like 10 terabyte a day now, for last year. So it's going to be, and these challenges are real. So services like OpenSearch can scale along with your data increase and also provide you the right performance you're looking for. So in terms of observability, the Ascend observability logs can be loaded into Amazon OpenSearch service we talked about for log analysis. And this is how like the integration between Ascend and all the other services is such crucial, because it provides like our customers with like different ways of hooking up like the services that you're using as part of the modern architecture, either natively or through a partner offerings like Ascend. Amazon Kinesis is obviously one of the really strong services we have there in terms of the real-time analytics. There's like different variety. There's a Kinesis data streams, there's data firehose, there's data analytics, there's video streams, and now there's a managed Kafka, we call it MSK. I won't go through each of them because they have it's like a world on its own. But basically, I want to kind of summarize like this particular thought process by saying that Ascend can digest data, can ingest data directly from the Kinesis stream. It can automatically collect the data and different stages, do the data partitions, and then do the processing through the data pipeline. So it reduces basically the need for custom code to write and maintain this integration through with Kinesis. Athena is an ad hoc service, a query service which user can avail in one of the native servers, and customers can use Ascend to automate the ingestion and processing of data into the clean data sets, S3 data sets, and obviously you can use something like Athena to kind of do the coding aspect of that. So let's talk about the seamless data movement. This is where actually, this is sweet spot for SN. Um, there are native services in AWS which helps with ETL, with visual data prep, with data replication, movement between data lake and data warehouses. Um, and if you have like dedicated engineering team, you can use the services and kind of tie them together and create that automation pipeline for that. But then then also, like, you also have the option for using something like SN, which makes it easier for even people with skills, not we don't have skills of data engineers to use and create these pipelines. So SN automation is all about making data movement fully automated, easy to use, and reliable through a single platform. So that's like the value of SN. Like, it's like, that's what we call it, better together story. So there is option through AWS services, but there's also like partners like SN, which kind of makes it easier, through out of box offerings, for people and teams we don't have the maybe so many skilled data engineers to actually do the same get the same result in terms of getting automatic pipelines. So so what is Ascend does? So let's spend some time in figuring out the value of Ascend platform. So as we have seen so far, AWS is excellent in solving scaling challenges around storage and infrastructure, and innovating at high speeds to take the undifferentiated workloads away from the customers. So AWS is already doing that. So what Ascend does is very similar. So what Ascend is doing is enabling engineering teams to develop solutions, by kind of, by keeping the inefficient heavy lifting on, on Ascend. So they are helping the customer to scale their team. So there's a scaling, the scaling aspect infrastructure is already done by AWS, but what Ascend is doing is letting companies who may not have such big teams or so many skills, like the deep skills needed for data engineers in their team, to achieve the same goal through making pipeline development easier, and kind of by moving the undifferentiated heavy lifting, like configuration, fine tuning, data lineage, optimizations, like kind of moving those undifferentiated heavy lifting, to something we call it control plane in Ascend world. And now what it does is that developers or analysts or data scientists can actually focus on developing what they need for the business. So most of the, almost 90% of the work is actually it goes through creating like those harnesses around pipelines, right? As I mentioned, like around like in lineage and perform and optimizations and configurations and error handling and garbage collection, right? So Ascend does that all out of the box, so the developers can focus on what is needed. So that's what I love about, like, the synergies between Ascend and AWS is basically like kind of moving the undifferentiated heavy lifting away from the customers. So they do that through, like, through the software stack they have, which kind of sits on the big data framework on AWS. Some of the common use cases for Ascend is like low code data ingestion, where you can move your data from anywhere to anywhere. And because they have a lot of connectors, read connectors, write connectors out there, which helps you do that. You can hydrate your data lake, basically from different sources. You can offload your data warehouse, and you can do optimizations. You can modernize your data platform, where you can migrate your on-prem to the cloud, from your traditional ETL. You can save your cost around traditional ETL, which could be expensive because you have to, you have to like burn so many like CPU cycles when you're doing those transformations. So it kind of helps you do that at a very low cost. So as a data engineers, we do same thing again and again. Hence, like, what it does is kind of automates a lot of those things out there for you. So typically you will use something like a Glue or an Airflow to schedule a pipeline, run the code, and push onto the service, onto the storage layer, or onto Spark, which will kind of process the data and put into a storage layer like S3 or RDSs. So Ascend can do that for you. It also it runs actually on the customer account, so you can buy it from marketplace. It runs on customer account where the data plane resides. The control plane is where all that heavy lifting is done by Ascend, and that's the magic of control plane they have. And the execution happens on like Spark. They also have other executions engine like Snowflake, where you can execute those transformations. So in broadly, they have logical plane, they have control plane, execution plane. Logic plane is the top plane where you can write a code of what you want to do and the code can be SQL or basically Scala or Python. And then basically the control plane does all the magic of how to kind of perform the code. And then the execution plane is basically your compute layer, which could be like a Spark mostly, and also Kubernetes where things are run and executed. This is a sample list of our joint customers, AWS and SN customers. And as you see, like they are pretty diversified, like from financial services, healthcare, then retail industry and the media. So if you look at from the top to bottom, like that's how different the market segments are, and it is supported like by growing ecosystem partners around the world, basically. So this is pretty impressive about what SN is doing as an AWS partner. And I know we are kind of getting close to the time, but so I'll try to kind of summarize a few things around governance and what SN is doing right now in terms of leaning in with us with AWS. They are launch partner to some of the key services out there. They're working really tightly with some of our service product teams to have end-to-end governance across AWS environment. Soon you will see a lot of like cool things coming out of like these collaborations with our teams. They have like AWS out of box integration with Glue catalog. They're also working with lake formation teams. So it is pretty exciting, like how next coming months and years you will see a lot of like cool innovations and functionality coming out of like these efforts. I won't go through the Redshift too much because I know we covered that, and there's a separate session for Redshift, which will Manan will cover a lot of the Redshift things. So I will not go and repeat myself on Redshift. And in terms of innovation, if you follow the reInvent and other releases, you see like we are innovating at AWS at a rapid pace. We have new services and features which keep on coming up. Like these are just one of those, some of the new features which were released during the last reInvent. And after that, and you see like, we are putting our effort to innovate to get our customers get best of the services so they can modernize their data architecture. So just to wrap it up quickly, Ascend is a very important partner with a unique platform that builds on the most reliable, massively scalable, and economically core AWS services. The key to Ascend is that you don't need engineers to write a lot of codes to manage it or process it or deliver data pipeline with the services. Ascend has done already the automation for you, and they can handle like thousands of edge use cases. And as a key AWS partner, they are adding a lot of value and are enabling a lot of like those use cases by integrating with our AWS native services. And with this, I will wrap this session up. And I want to thank everyone out there to have attended the session. I hope everyone took something valuable from this session. If you have any questions, you can always email me. At my email address on Amazon, it should be there or you can connect with me on LinkedIn and ask me whatever questions you may have and challenges you may face. And with this, I thank you again for attending the session, and goodbye.